Alrighty, ladies and gentlemen, we're doing the third video on the spring midterm review. Why do I have spring two times again? I don't know. Sorry. On the midterm review for spring 2024. Okay. On the first video, we covered solving systems. That's the first part of the midterm. On the second video, we covered the 7 rules of exponents and also growth and decay functions, exponential growth and decay functions. And on this third video, we're going to cover the third part of the midterm, Unit 8, polynomials, adding, subtracting, multiplying, and classifying, and also review of multi-step equations. Let's jump right in. So if you're watching this at home, it'd be a good idea to take some notes. I would write down Unit 8, polynomials, add, subtract, multiply, and classify. So let's first begin by analyzing these questions that we need to do. We need to simplify these. And the reality is you have a polynomial with a plus sign and another polynomial. You are adding on this first one. On the second one, you are subtracting polynomials. You are not multiplying. Where do we multiply? When there is no sign between the parentheses. When there's no sign between the parentheses, or when you have parentheses with something in front where there's no sign between that something and the parentheses, that's when we're multiplying. So we are not multiplying here and not multiplying there. I keep seeing students trying to distribute 4x to the third times that. No, that's wrong. You are not multiplying when it says plus between your polynomials or a minus between your polynomials. Okay, so right here at this first part of the video, I'm going to add these polynomials. I'm going to subtract these polynomials. I'm going to multiply these binomials with each other. And I'm going to multiply this binomial with the trinomial, and I'm going to multiply this monomial with the trinomial. Anyway, I'm not going to worry about classifying till later. Let's begin by adding. Well, first of all, if you are adding, then there's really no need for the parentheses. You could just start combining like terms. As a matter of fact, let's just say this before we even begin. When I say add or subtract, the add doesn't really mean that you're going to be adding all the time, or the minus doesn't really mean that you're going to be subtracting all the time. The reality is, when you have a positive sign in front of your term, that means that you have. When you have a negative sign in front of your term, that means that you owe, and you're combining like terms. So instead of thinking of adding and subtracting, think we're going to be combining positive and negative terms. So once again, whenever you do have parentheses with something out in the front, you'd have to distribute it. Now there's nothing out here in the front, so you could pretend that there's an invisible 1. And if you went 1 times 4x to the third, it would be 4x to the third. Nothing happens. Nothing happens to this guy. Nothing happens to this guy. They all stay the same. I apologize for me going crooked. Anyway, the plus sign, that's really like a positive 1. If I distribute it there, it's not going to change anything. So it's going to stay exactly the same. It's going to be a negative 6x to the third. It's going to be a positive 7x squared. It's going to be a minus 9x. In other words, when you have a plus sign, you could just ignore the parentheses and start combining like terms. What do I mean by combining like terms? I'm talking about x squares with x squares, x's with x's, numbers with numbers, x cubes with x cubes, right? So let's begin by combining the terms with the highest exponent, because we want to write it in standard form, which would mean highest exponent down to smallest. So we have a 4x to the third here and a negative 6x to the third here. That'll be a negative 2x to the third. Zoom in on this a bit. And then we're going to move on to x squares. Well, I have a negative 2x squared there and a positive 7x squared there. So that's like if I owe 2 of these guys and I have 7 of those guys. So you owe 2, you have 7, you're going to have 5 left over. You're going to have 5 of those x squares left over. Okay, notice that when you're adding or subtracting, exponents do not change. Right here, you had 4 of those x to the thirds, you subtracted 6 of those x to the thirds, negative 2 of those x to the thirds. Right here, you owe 2, you have 7, you're going to have 5 left over of those x squares. Also notice that when I combine my x to the thirds with x to the thirds, I circled them. I didn't circle the x squares with x squares because ultimately everything gets circled and that gets confusing. So what did I do? I used a different type of symbol to show that I'm combining a squiggly underline on the negative 2x squared, squiggly underline on the positive 7x squared. Moving on to our final term that we could combine, the 5x with the minus 9x. You owe $5. You have $5. You owe $9. You're gonna owe 4 of those dollars. And that's our answer, okay? Nice and simple. When you're adding, you could have started right from the start. Okay, 4x to the third minus 6x to the third, that's negative 2x to the third. Negative 2x squared, positive 7x squared, that's positive 5x squared. 5x minus 9x, that's minus 4x. So you could have done this in your head without showing this work. I just wanted to show in detail how I got the answer. Again, with the plus sign, you just start combining like terms. With the minus sign, on the other hand, this is saying that you're going to subtract this whole entire thing. So to make things less confusing, let's distribute the minus sign, kind of like if it were a negative 1. Say negative 1 times that, that'll be a positive 4x. Negative 1 times that, that'll be a positive x squared. Negative 1 times that, that'll be a negative 7. Now there's nothing to distribute over here, so we're just going to bring it down. Negative 6x plus x squared minus 2. And now, after we change these signs, now we could actually combine like terms. And since we want our answer in standard form, from the highest exponent term down to the smallest, we're going to begin with our highest exponent terms, a positive x squared and a positive x squared. So you got one of these guys and another one of those guys. So how many do you have altogether? You have 2 of those x squares. Then we move on to the x's. Well, we have a negative 6x right here, squiggly underline, and we have a positive 4x right there, squiggly underline. You owe 6, you have 4. You can't completely pay them off. You could give them the $4, but you're still going to owe $2. In this case, you're still going to owe 2 of those x's. And last but not least, you owe 2, you owe 7. You're going to owe 9 of those guys. So there's our answer, negative 2x squared minus 2x minus 9. Once again, these first 2 problems was just adding and subtracting. You could just say combining like terms of these polynomials. Polynomial plus a polynomial, combine like terms. X to the thirds with x to the thirds, x squared with x squareds, x's with x's. If you had numbers by themselves and numbers by themselves, you get a number at the very end. Over here, we're subtracting, which means we distribute the minus sign, and then again, combine like terms. X squares with x squares, x's with x's, x's with x's, and numbers with numbers. Right here, we are not combining like terms. Well, not yet. Right here, we're multiplying, right? You're adding, subtracting, that means combining like terms. Right here, you're multiplying because there's no sign between the parentheses. So right here, we're gonna multiply. The thing is, we have a binomial. We have 2 terms. So we have to distribute one of them at a time. I'm gonna distribute the 2x first. 2x times 3x is 6x squared. 2x times 4 is 8x. Now, if you're thinking, what? I don't get it. How am I multiplying 2x times 3x? Multiply the coefficient 2 times the coefficient 3. It gives you the 6. Multiply x times x. When you're multiplying 2 variables, the exponent pops up, x squared. Exponents change when you're multiplying with the same variable. Rule 1 of exponents, that when you're multiplying the exponents, you add them. So 1 plus 1 is 2. Anyway, when you distribute over here, 2x times 4, well, yeah, 2 times 4 is 8, and x, you just bring it down. If there were another x right here, you would multiply the x times x. If you had an x squared, you'd multiply that x with the x squared, but you get the idea. So you've already distributed the 2x. Now let's distribute the minus 5. Minus 5 times 3x, that's minus 15x, and that's it. Why? Because the number negative 5 times the number 3 is negative 15. What about the x? Just bring it down. Then distribute the minus 5 to the positive 4. Negative 5 times positive 4, negative 20. Okay. If you could combine like terms, which we can right here, the 8x and the minus 15x, those are like terms. You could combine x's with x's. And let's combine them. You have 8, you owe 15. You're going to owe 7 of those x's. What about the 6x squared in the front? Just bring it down as the first part of your answer, 6x squared. What about the minus 20 at the back? Bring it down and put it as the last part of your answer. And there's your answer, the quadratic trinomial, 6x squared minus 7x minus 20. So again, notice the difference, guys. Right here, there was no sign between the parentheses. I have to distribute and multiply. I'm not distributing over here. There's a plus sign there. There's a minus sign there. All you do is combine like terms. Right here, no sign between the parentheses, no sign between the polynomials or the binomials, to be more specific. So you're going to be multiplying, so you're going to do distributive property one at a time. over here, we have the same situation, but instead of a binomial, 2 terms, times a binomial, 2 terms, you have a binomial times a 1, 2, 3 trinomial, okay? So we're going to distribute one of them at a time. 2x times 2x squared is 4x to the third. Again, 2 times 2 is 4. X times x squared is x to the third. Now distribute 2x times 4x. Well, 2 times 4 is positive 8. And x times x is x squared. Then we move on and distribute 2x times that last one. 2 times 3 is 6, and bring down the x with it. So we've distributed the 2x to all 3 terms. We get these 3 answers. Now let's distribute the plus 3. I'm going to use a different color. Plus 3 times 2x squared, that becomes 6x squared. So you could write it right here to the right of it, but later you're going to have to combine it with this x squared term. So maybe instead of writing it to the side, it's better to start stacking them so it'll be more organized. So I'm going to put that 6x squared, I'm going to put it down here, right below the other x squared term, okay? And now let's distribute 3 times 4x, that's 12x, positive 12x, and notice that I write it right below the other x term. That way it's easier to combine the like terms, all right? And last but not least, 3 times 3 is 9, and there's no regular number, so it's just there at the end. Now we could combine like terms, which normally we'd be using like circles, underlines, squiggly underlines, but because we stacked them, we don't have to worry about circling the like terms that we're going to be combining. As you can see right here, 4x to the third, there are no other x to the third terms, so this just comes down, and that's the first part of our answer, 4x to the third. 8x squared plus 6x squared, you're just combining 8 of these guys plus 6 more of those guys, that's going to be 14 of those guys. Exponents don't change when you're adding or subtracting. And then over here, plus the 6 plus 12, that's 18, plus 18 of those x's, and the plus 9 at the very end just comes down, right? All we did was bring that down, combine those, and that we just brought down. And there's our final answer, okay? Final answer right there. So again, the first 2 examples we did, we were adding and subtracting. That's just combining like terms. We distributed here, and we're going to distribute here, but this is the easiest one of them all, because right here we had 2 terms to distribute into the 2 terms. Right here we had 2 terms to distribute into the 3 terms. Right here you only have 1 term to distribute into the 3 terms. So this is going to be easy. Check it out. Let's distribute negative 3x squared. Let me zoom in actually. Negative 3x squared times 6x squared. Well, what is negative 3 times positive 6? That's negative 18. And what about the x's? What is x squared times x squared? I'd have to add those exponents. It's going to be x to the 4th. Now let's distribute the negative 3x squared times that negative 1x. Okay, well, simple. Negative 3 times negative 1 is a positive 3. And of course, x squared times 1 more x is going to be x to the 3rd. And last but not least, negative 3x squared times positive 8. Well, negative 3 times positive 8 is negative 24. And of course, there's only the x squared. There's no more x's to multiply. So just take that x squared and bring it down. And that's your answer. Okay? So that is a certain portion of Unit 8. We simplified polynomials. So we added, we subtracted, we multiplied many different ways. And we also have to classify polynomials. So, and know some vocabulary. This is the page of notes that we had on this section. And classifying polynomials is ridiculously easy. You have a first name and a last name. The first name is based on the degree, the highest exponent. If your highest exponent is 4, the first name is quartic. Highest exponent 3, cubic. Highest exponent 2, quadratic. Highest exponent 1, linear. The last name is based on the number of terms. Now, what do I mean by number of terms? If you have like something plus something, and you can't actually add them, that's what you call a binomial, something plus something. If you have something plus something minus something, that's what you call a trinomial. That is if you can't combine them, right? Something plus something plus something, that's three terms, trinomial. If it's just one term, it's monomial, okay? So if I were to look at, let's say, the first answer right here, the first name is based on the exponent. The highest exponent is 2. So if you go to the highest exponent of 2, that's called a quadratic. And because there's 1, 2, 3 terms, you weren't able to combine them at the very end. They're not like terms. So that's 3 terms. That'd be a trinomial. So first name, quadratic, based on the degree. Quadratic. Last name, trinomial. Why trinomial? Because there's 3 terms. 1, 2, 3 that you're adding or subtracting, okay? What if, like, you just had this guy right here? What would the first name be? Well, the first name is based on the highest exponent, and the highest exponent is an invisible 1. So that would be first name linear. And since there was only one term right here, like it doesn't say negative 2x plus 5, that'd be a binomial. Or like a x squared minus 2x plus 5, that'd be a trinomial. It's just one term, so that'd be a monomial. So once again, highest power is 1, linear, only one term, monomial. So linear, monomial, right? This guy right here, highest exponent's 3. Oh, cubic. How many terms do you have? You have 2 terms, binomial. So cubic binomial. So it'd be good to go back and review this stuff because this stuff will pop out on the midterm. Also, we need to know like leading coefficient, constant, and all that good stuff. What do I mean by standard form? We've been talking about standard form. It has to be written with the highest exponent first, all the way down to the smallest in order, highest to smallest, with the constant at the very end. You see this answer that we have right here, it's in standard form. Highest exponent's 2, and then the power of 1, and then the constant without even a variable. So this is standard form. The degree is the highest exponent, which is 2. The word coefficient simply means the number in front of your variable. Okay, so the coefficient of x is -7, the number in front of x. If I say what's the leading coefficient, I'm talking about the number that's out in the front when it's in order like this in standard form. Okay, so what if you had something that's not in order? Like let's say, let me just go over here to the side. And let's say if I had like a 3x minus x squared plus 5, that's not in order. If I ask you for the leading coefficient, if you say 3, you're going to be wrong. Because in order for you to identify the leading coefficient, you got to think of it as if it's in order. You got to rewrite it in order first to see the leading coefficient. This is the highest exponent term. That should be in the front. So let me rewrite it in standard form. Negative x squared with a positive 3x next with a plus 5 at the end. So your leading coefficient would be -1. The leading coefficient is a -1. Why? Because when it's in order, the number that's out in the front is -1. Okay, it's not 3. How about the word constant? Constant means it does not change. So the constant will always be the number without a variable, without an x or without a y, without a letter. You see, plus 5, positive 5 will always be positive 5. You see this 3 right here? It's not always going to be 3. It might be 3 if x is 1. 3 times 1 is 3. But it might be 6 if x is 2. So this is not constant. It's going to vary depending on that variable, whatever that x actually is. So the constant is simply saying the number without a variable. And all that stuff will be on the midterm. Let's move back over here. And I almost forgot, we got to solve multi-step equations. There's at least one of these long multi-step equations that we need to solve on the midterm. So let's jump right in and do this one. Let's begin by reviewing what we need to do to solve. Step 1 is to simplify each side. You see there's 2 sides to the equation. There's the left side of the equal sign and the right side of the equal sign. You need to simplify both sides one at a time. What does simplify mean? It means a distributed property and then combine like terms. The number one mistake I see students make is that they see 5 take away 3 and they say, oh, 2, wrong, it's not 2. Because you can't subtract before multiplying. PEMDAS, you got to multiply before subtracting. So you actually need to distribute first. Distributive property first. Negative 3 times x, negative 3x. Negative 3 times positive 4, negative 12. Bring down that 5 that's out there in the front. Now you have 1, 2, 3 terms. Out of those 3 terms, you could combine the 5 with the minus 12. You do this in your head. You don't show any work. 5 take away 12, you could do it on a calculator if you want. That'll give you a negative 7. So 5 take away 12 is a negative 7. What about the negative 3x? Simply bring it down. So this entire left side, the 5 take away 3 parentheses x plus 4, that whole thing became a binomial, negative 3x minus 7. That's what you call simplifying. Look, it was huge from here to here. Now it's simple 2 terms, negative 3x minus 7. That's what you call simplifying. We simplified the left side. Now let's simplify the right side. On the right side, we're going to distribute 2 times negative x is negative 2x. 2 times 3, that's positive 6. And we're going to bring down the minus 9 that's over here at the very end. I just rewrote it. I have 1, 2, 3 terms. What could I combine out of those 3 terms? I could combine the 6 with the minus 9. Do this in your head or on a calculator. 6 take away 9 is negative 3. What about the minus 2x? Bring it down. Okay. So this huge, nasty right side of the equation, I simplified it. Now it's more simple. This whole thing became a binomial, negative 2x minus 3. Okay. Now that we've simplified it, right, this huge, nasty equation now became a smaller, simple equation. The equal sign is still right here. I'm going to drop it straight down right there. And here's my new simple equation, a binomial on the left side of the equal sign, a binomial on the right side of the equal sign. I want to get x by itself on one side of the equal sign. Where's the x at? Is it on the left side of the equal sign or the right side of the equal sign? It's on both sides of the equal sign. I don't want it on both sides. I want to get x by itself on one side. So it's totally up to you. You could move the x to the left side or you could move this x to the right side. Totally up to you. I am going to choose to move the minus 3x over to the other side by adding 3x. You see, negative 3x plus 3x cancels out. And what you do to one side of an equal sign, you must do to the other side to maintain the equality, right? So what do we have left? We have a negative 7 equaling, when I combine minus 2 plus 3, that's a positive 1. So I'm just going to put 1x, or you could just put x. You don't even need the 1, okay? And what about the minus 3? Simply bring that down. So I used to have x's on both sides. I got rid of one of them. Now I only have x on one side, okay? I need to get this x by itself on this right side of the equal sign. So I'm going to get rid of the minus 3 by doing the opposite, plus 3. What you do to one side, do to the other side, plus 3. What do we have left? We have a negative 7 plus 3. That is a negative 4 equaling x. So that is your answer. All you got to do is write it the right way or the nice way. X equals negative 4. That is your answer, okay? So, of course, you should know this from semester 1. I just did one example. You will have this on the midterm, at least one question like this. So please make sure you understand to distribute first, then combine like terms on both sides. That's what we call simplifying. And then worry about getting x by itself on one side of the equal sign. And if you have x's on both sides, move one of the x's so it could just be on one side. And then get x by itself on that one side. Alrighty. Whew. It's been a long one. I apologize. I hope this helps. Good luck on the midterm.